4 different phases. I'm just gonna write this down, like before titration. And what happens if there's 40 milliliters, which is to say before equivalence point. What happens at equivalence point, or in what happens if there's an excess of base. Now, this is sort of the same thing, but because it's a weak acid, in this case acetic acid, so we're gonna do something kind of different. And we all know, I think, I'm assuming that you all knows how to calculate the pH of a weak acid, which is using Ka. We want to look up the Ka value for the weak acid that we're using, either in reference book or in blue book, or it will be given to you in problem, so you don't have to worry about that. And the thing is with this problem is that you have to find the concentration of hydrogen ion, and it's not easy because this weak acid does not dissociate completely into this. So what you want to do for this type of problem is you write out the equation where it dissociates into its conjugate base and the hydrogen ion. So at beginning, and we set up sort of a sort of a box where we can find this. Alright, so this is before any of the base is added, so we don't take into account this. So we're already given 0.1 molar, and at the beginning nothing's happening yet, so 0, 0. But as you know, there's certainly some sort of dissociation happening before we add the base, so it's gonna dissociate some sort of this type of amount of concentration, and of course you have to plus x over here because the concentration of this is gonna go up, right? So it should be 0.1 minus x, and what we want to do is we want to find x, which is the concentration of the hydrogen ion at the beginning of titration. And after we set up this type of box, we can easily go on to say that, let's see right here, Ka, because Ka is the concentration of the conjugate base times concentration of hydrogen ion over the concentration of the weak acid that we're using. And in this case, since we already put it in x and stuff, we find x times x, or x squared over 0.1 negative x. Now we already know what Ka is, and we must find the x to find the concentration of the hydrogen ion. Now, for many types of problems, you do, since the x is so small compared to this, but we can assume the denominator to be just 0.1 only, because we don't want to deal with complex quadratic formula for this, and in many cases we do have some sort of multiple choice questions for these type of questions, so we want to be as simple as possible. So find hydrogen concentration, find by finding x, and then find pH, which is pretty easy. Alright. Now the second phase of this, I'm just gonna write this down, is that some base is added, but it's not enough to make this go into equivalence point yet. So what happens? Well, so basically you must find the concentration, again, you must find the concentration of the remaining acid after some base is added. And then what you want to do is to find the concentration of the conjugate base. In this case, is the same as conjugate base is CH3COO minus is equal to the concentration of the NaOH added, which is 0.1 times 40 milliliters over 90 milliliters, because this is the new volume and this is the volume of the base that is added. And we all know because this is 1-to-1 ratio, so if you put in 40 milliliters of this, you will get the same amount of concentration, because this is in excess, or in stoichiometry terms you can say it's limiting reactant. So we're gonna base everything on this, and so that's how we find the concentration of conjugate base. And we find whatever this number is. I know it's nasty, but and what we want to do is, again, set up the icebox thingy, which you already did, and just gonna write this down. 3COOH CH3CO minus plus hydrogen ion, and yeah, beginning change and equivalence point. Now some of this has already been neutralized by this, so we must find the concentration of the remaining acid. I'm gonna calculate that out, but you get the idea. And this we already find, which is the concentration of the base. So, and this we don't know yet. We don't have it yet. So it's after some time it's gonna dissociate. We have this. So after a while we have sort of whatever that is, and we have whatever this is. And again, we have to find this based on the Ka value of this. So Ka in this case should be plus x should be something like plus x times x over concentration of this minus this. Now